Hello everyone, welcome to SS classes. In today's lecture, we are going to discuss about the chapter 3 part formation of ionic compounds. So in today's lecture, we are going to discuss about the steps involved in the formation of ionic compounds. So before discussing the ionic compound formation in detail, students, let's discuss about what are the ionic compounds. So student, ionic compounds are formed when metal reacts with non-metal. In your previous classes, you learned that metals are electropositive. It means they loses their valence electron and get positive charge, while non-metals are electronegative. It means they gain the electron and ultimately get the negative charge. So, what are ionic compounds? Ionic compounds are formed by losing and gaining of electron by metals and non-metals respectively. So, basically, in ionic compounds, the ions are present. Its word indicates ionic compounds. Okay, ionic. Ionic means what? That the particular compound have ions in that. And what are those ions? So those ions are cations and anions. Okay, so these cations and anions you know very well in your previous classes. You learned that what are cations and what are anions. So cations are formed by metals, okay, and anions are formed by non-metals. Okay, so cation means positively charged atom. Okay, positively charged, and anions means it's a negatively charged. Okay, it's a negatively charged. Okay, for example, Na, sodium. When sodium loses its outermost electron, ultimately get positive charge. Okay, and when non-metal gains, when metal loses electron, they get positive charge, and when non-metal gains the electron like chlorine, it ultimately gets the negative charge on it. Why this is so? Because student, you know very well that in neutral charge atom, the protons and electrons are present in equal number. For example, sodium. So atomic number of sodium is 11. What does it mean? It has 11 protons in its nucleus and 11 electrons are revolving around the nucleus. So if the equal number of positive and negative particles are there in an atom, so its neutral charge is 0. Okay, but so its net charge is 0, it means it is a neutral atom. But when sodium loses its 1 electron, then the proton remains in the same number while 1 electron gets lost during the reaction. So due to loss of 1 negative charge, only the 10 electrons are remain in such atom. So if we compare the total number of electrons and the total number of protons for that particular atom after losing 1 electron, so you will come to know that the 1 positive charge is more. Okay, it means the 10 electrons are there and 11 protons. So 10 electrons are neutralized by the 10 protons, while the 1 positive charge in the nucleus of an atom is more, and hence ultimately the sodium get 1 positive charge. Okay, in the same way, when 1 electron is increased in a neutral charge atom, so ultimately it becomes 6 single negative. Okay, so when metal loses electron, then metal gains positive charge, and when the non-metal gains electron, okay, it loses and it gains. So when it loses, it gets positive charge. When it gains, it gets negative charge. So basically, when metal loses electron, non-metal gains those electron, and ultimately there is a formation of an ionic compound in between the metal and the non-metal. Okay, so let's discuss what are the steps involved. That how will you represent the formation of an ionic compound. So children, here we have the first example of ionic compound, and that is the sodium chloride. And basically this ionic compound formation by electron transfer method. This kind of question when asked many times in the board examination for 3 marks. Okay, so you have to prepare accordingly, and you are going to write 3 steps in that. So let's discuss what are the steps involved. So the first ionic compound which you have in your syllabus is sodium chloride. Okay, so our first ionic compound is sodium chloride. Let's discuss what are the steps involved in the formation of ionic compound, that is sodium chloride by electron transfer method. So in that we are going to write the formation by 3 steps. Let's discuss what are the steps. So in a question sodium chloride, you have to first identify that what are the metals and what are the non-metals. So basically here in this question, the sodium is the metal, okay, while chlorine is non-metal. Okay, now we are going to write the steps involved. So the first step that we always write in formation of an ionic compound is the representation of the metal present in that particular ionic compound. So what is the metal? Sodium. So let's write about it first. So the step first is, in this ultimately we will write few more steps. So the first step that we will write is the element, type of element. So the type of element is metal. Okay. Second step, what kind of element is that? So it's metal, so we will write its name in the next step. So its name, of course, sodium. Okay. In the next step, we will write its symbol. Okay. Its symbol is Na. Okay. In next step, we are going to write its atomic number. So its atomic number is 11. Okay. Now, note down its electronic configuration. Its electronic configuration. So its electronic configuration is, let's distribute this 11 electrons according to the capacity of shells. So the first shell is a K shell and it can accommodate only 2 electrons. Then the next shell is L, it can accommodate 8 electrons. So out of the 11, we have already represented 10 electrons. Now the one is remaining, that we will write in the shell N. So the electronic configuration of the sodium, whose atomic number is 11, is 281. Now we are going to just highlight this last step because we are going to write this many number of electrons in the next step. So the 6th step is writing electron dot structure. Electron dot structure. Okay children, now how to write the electron dot structure? So student, in the electron dot structure of any element, we write the outermost electron present in that particular atom. For example, here is the sodium. So how to write electron dot structure of sodium? So first of all, we have to find out that how many valence electrons are present in that particular atom. And children, you know very well what is meant by valence electron. The number of electrons present in an outermost shell. So in case of sodium, M is the outermost shell. And how many electrons are there? 1. So in electron dot structure, we are going to write the last shell's electron. So it's 1 only. So first of all, we will write its symbol, that is Na. Okay. And we are going to now write the valence electron. So one valence electron is present in the sodium, and that we will write by the symbol dot. Okay, like this. Na dot. Okay. Na dot. And now we are going to make a bracket for this electron dot structure of the sodium. Let's write the step second. Step second. Okay. It is also similar like a step 1, but for this we are going to write about the non-metal. Okay. So the step 1 is element. So what the element we have here? Second element is non-metal. Okay. What that non-metal is? Its name is chlorine. Okay. Its symbol is Cl. Okay. Its atomic number is 17. Its electronic configuration. Okay, electronic configuration. Let's distribute 17 electrons according to the capacity of the shell. So you will get electronic configuration K2 L8. So we have already written the 10 electron out of the 17. 7 are remaining, and that we will write in the M shell. Now we are going to highlight this electron because we want to represent in the next step. Okay. So here the step 6. Electron dot structure. Electron dot structure. Okay. So as I told you, in the electron dot structure, we write valence electron of that particular element. Okay. So here the 7 electrons are there in an outermost shell of the chlorine. So we will write by writing its symbol first and by writing the 7 electrons. But now we have to change the symbol. Here, as we have written dot for the electrons of metal, so here we will change the symbol. So for this we can use cross symbol. Okay. So first we will write its symbol Cl. Okay. And now we want to write this 7 electron. Now we will use the symbol cross for writing this electron. So this is 1, 2, 3, 4, 5, 6 and 7. So we have represented 7 electron, and this is the electron dot structure. Children, do remember, in this step you are not going to write the total number of electrons present in that particular atom. Okay, you have to just write an outermost electron. Okay, so now here we will put again the box for the electron dot structure of non-metal. So here we have completed step 1 and step 2. Now the step 3 is remaining, and what is that? And the step 3 is very important step for the formation of ionic compound by electron transfer method. Okay. Here you can also add one more point, and that is what? For example, this is the metal sodium. Okay. So this is the metal sodium. Now this metal is going to lose its electron. So we will write the sodium, when it loses electron, one electron, it becomes Na plus electron single minus. Okay, क्या करता है सोडियम? When sodium loses its one electron, after losing its one electron, it get positive charge. And here what you can write, children. See, for example, here is the chlorine. Okay, so when chlorine gains that electron, it becomes chlorine minus. Okay, it becomes chlorine minus. So these are the step 1 and step 2. Now we are going to cover the very important step in the formation of an ionic compound is, and that is the step 3. Now you have to focus more on the step 3, children. Okay, these are very easy steps where we just write the basic information about the metal and non-metal. Now the step 3 is very important. So let's see what is the step 3. Now children, for this step 3, you have to remember the electron dot structure from the step 1 and step 2. So basically, in the step 3, what we write first? In the step 3, we write about the metal that is getting involved in the reaction, and this is the sodium. Okay, so we will write Na. But not only metal, we have to write its electron dot structure. So metal's electron dot structure for the sodium is Na single dot. Okay, and now which non-metal is getting involved here? Chlorine. So we have to write electron dot structure of chlorine. What is electron dot structure of chlorine? It's 1, 2, 3, 4, 5, 6 and 7. So this is about the electron dot structure of metal, electron dot structure of non-metal. Now what we have to represent here? This is the very important step. So now in this reaction you have to represent that from where the electron transfer to where. Okay, so basically the electron transfer from metals to non-metals. So that we will write by drawing the arrow from the electron of the metal to the non-metal. So simply what we will do, we will just draw arrow like this. Okay, so the electron is getting transferred from here to here. Okay, now metal loses electron and non-metal gains that electron. Then what happens? Then after the reaction, the compound is formed, and that is the NaCl, and that compound ions are present. So for metal, basically NaCl means this is the NaC. Okay, that we will write in the form of ions. How? So for first, what is first? Metal. So for this we will put a bracket. We will write Na. Now the sodium loses one electron. So as it loses one electron, it gets one positive charge. So we will write that single plus here. Now we will complete the bracket. Then we put square bracket directly. Don't put a plus sign here because this is the compound. Okay, where the sodium and chlorine are chemically bounded. Okay, now we will write about the chlorine. So this is the chlorine. So what is the previous structure of the chlorine? This one. So we will draw that 1, 2, 3, 4, 5, 6 and 7. Now the chlorine have one electron from the sodium. Okay. So we will draw that electron which has been transferred from metal to non-metal. So that we will represent here. And once the chlorine gets one electron, it ultimately gets single negative charge. So that we will write here. Okay, metal loses one electron, so metal gets positive charge. And that electron is gained by non-metal. So non-metal gets negative charge. Okay, the one who loses electron get positive charge, and the one who gains electron, the one who accepts the electron, get negative charge. Okay, so this is the formation of compound NaCl by an electron transfer method. So here this is the formation of ionic compound by electron transfer method. Okay, so we have completed the first question, that is sodium chloride. Let's discuss the next question, that is the formation of magnesium chloride. Okay, so our second question is magnesium chloride. So the second one is magnesium chloride. Now I am not going to write the name, I have directly written the symbol of that compound. Let's carry out the steps. Okay, so you know very well now the step 1 is what? We will write about the metals. Okay, so the first one is element. Element is metal. What its name is? Its name is magnesium. Okay, now what is the step 3? Its symbol we write. So its symbol is Mg. Now its atomic number. Its atomic number is 12. Its electronic configuration. Its electronic configuration is K2L8M2. Its electron dot structure. Electron dot structure is, how we will write here? We will write Mg and 2 dots, dot 1 and dot 2, and now we will put bracket for this. Okay, this is the step 1. Now we will carry out the step 2, which we have already done for the chlorine. Okay, so what is the element? Element is non-metal. Its name is chlorine. Its symbol is Cl. Its atomic number, children don't use short forms, okay? Here I have written, you don't use in your examination. So its atomic number is 17. Its electronic configuration K2, L8 and 7, and its electron dot structure is chlorine 1, 2, 3, 4, 5, 6 and 7. Again I am repeating, please don't use these short forms in your examination. Write in full words. Okay, and now we will write here also that Mg, okay, it's going to lose 2 electrons. So once it loses 2 electrons, okay, once it loses 2 electrons, it get 2 plus charge. So it get 2 plus charge. And now the chlorine, okay, chlorine is going to, one chlorine is going to accept 1 electron. Okay, so there will be a Cl minus. Okay, now we will write step 3. Okay, so step 3 is very simple. Okay, so step 3, look at the formula of the compound first. So here the Mg, so we will write Mg here. Now how many electrons were there in an outermost shell of magnesium? Just recall the electronic configuration. So it had 2 electrons. Okay, so we will write 2 electrons like this. Now how many chlorines are there in the compound? 2 chlorines. So you have to draw 2 chlorines there, 2 chlorines. Okay, chlorine 1 and chlorine 2. Okay, now how many electrons? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6 and 7. Now the magnesium is going to lose 2 electrons, but one chlorine can gain only 1 electron. Now how we will represent it? So it's very simple. Just transfer 1 electron from here to here and 1 electron from here to here. It's very simple. Otherwise you can draw this electron here also and you can represent in this way. Now the next step is very important. Listen carefully, children. Now here what we will write? What is in the formula first? Mg first. So we will write single Mg here. Now as it loses 2 electron, it gets 2 plus charge. Okay, see, Mg, it loses 2 2 electron, so it get 2 plus. So we are going to write 2 plus, Mg 2 plus. Okay, and now chlorine. Now look at the chlorine. How many chlorines are there? 2 chlorines. So don't write 2 chlorines here in the product. Okay, represent only single element. So this is the chlorine. So we are going to represent the previous one. 1, 2, 3, 4, 5, 6 and 7. One chlorine gains 1 electron. So we will write that electron. And as it gains 1 electron, it gets 1 negative charge. So this is the 1 negative. And such how many chlorines are there in the reaction? 2 chlorines are there. So we will write 2 here. Okay, don't write 2 here. Okay, you are not going to change the formula of that substance. No, formula should remain same. So we will check that whether our formula is correct or not. So look at this, Mg single, okay, Mg single. Chlorine 2, check, chlorine 2. Okay, so this is the formation of an ionic compound, magnesium chloride, by electron transfer method. In this way, you can complete a few more examples such as AlCl3 also you can form, okay, N2O3 also you can form, okay, then Na2O, MgO, okay, many compounds are there. So you can try for these compounds which I have given in the homework here. Okay, and children, if you have few more doubts, you can drop in the comment box. So I will try to prepare video for those topics. Okay, now this is about our today's lecture. In today's lecture, we discuss about the formation of an ionic compound. Okay, where we discuss about the two examples, that is sodium chloride and magnesium chloride. And few examples I have given here for you for the practice. So try to form the ionic compounds by the electron transfer method. Okay, children, if you like my video, please don't forget to like and subscribe my video. Okay children, bye bye and take care.